Hi, welcome to today's lesson. What I'm looking at today is factorizing a difference of two squares. You need to have seen factorizing quadratics first. Okay, so difference of two squares. Okay, dots, difference of two squares. It's written out in full on the notes below. Okay, so let's take a look at this. This is very straightforward. Basically what this means is that if I've got x squared minus y squared. If I've got a difference of two perfect squares, this factorizes into x minus y, x plus y. Okay, for the explanation of why that works, go watch the video on special quadratics, that I multiply out quadratics. You'll see that when I multiply this out, the middle term, if I had to multiply this out of xy, will cancel. Okay, the two middle terms cancel. The o and the I of FOIL will cancel. And you just have to with the front squared minus the back squared. Okay, so let's take a look at this. This is very straightforward. E.g., x squared minus 16. X squared minus 16, well, that's a perfect square, that's a perfect square. So all this equals is x4, the square root of 16 is 4, plus minus. The order doesn't matter. If you go x minus 4, x plus 4, it doesn't make a difference. Just straightforward as that. Okay, and this is quite a quick one, so let's just quickly do the next one. Last one, e.g., 10x squared minus 250. Okay, so this is where they could mix two different types of factorizing together. You go, oh great, well that's x squared, that's a perfect square. This looks like it wants to be a perfect square, because if that was 25 it would be fantastic. But unfortunately 10 is not a perfect square. Well, let's take out a common factor first. So let's see what happens if I do this. If I pull out a 10 in the front there, I'm left with x squared minus 25. Pull out a 10 from there, pull out a 10 from there, I got 25. Wow, look at that. There's a difference of two squares. So I've got 10, and I've got x minus 5, x plus 5. Okay, and we're done. Now, when you're dealing with factorizing quadratics, you must always look for all the factorizing that you can do. Most of the time, it's just going to be a straightforward factorizing two brackets. The more challenging ones will have two different types of factorizing built into it. So in this case, I've got a difference of two squares, but I also have taking out a common factor. Okay, so you should always check. If I can't factorize it immediately, can I take out a common factor, and then will something else come up? By the way, I've seen people take out a common factor and leave it like this. This is not the end answer. They say factorize, all right? You cannot leave it like this. You got to go until there's nothing else that can be factorized. Nothing else, okay? This is not sufficient. As a suggestion, I always say this to my class, is that you should learn to recognize the first 15 square numbers, okay? The list is on the page there. I was going to write it up, but I'm not going to. So you can read it on the page underneath. Okay, the first 15 square numbers, up to 15 squared is 225, at least, okay? That should be sufficient, especially if you're in a non-calculated exam, okay? Because if you don't recognize that's a perfect square, you know, you've got a problem, okay? The other thing that I would suggest is I'd also suggest that you learn the first 5 perfect cubes. Well, five perfect cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Okay, in my experience with my teaching career in high school as well, those are the ones that I think that you need. The first 15 squares and the first 5 perfect cubes. Okay, alrighty, that's it. Short, sweet, done. Remember, I'm here for you.